Alright, time for another DraftPhysics.com video presentation. This is kind of a quick video just on a very specific subject, essentially just to Dispar, who's doing a coupled oscillator experiment. And I just want to point out a couple of things before he starts attaching devices to do measurements and whatnot regarding stuff that he probably would want to fix before. Why isn't it highlighting? Is he going to move my arrow? No. Damn. It's always something. Something always has to not work for some stupid reason. Alright, appears to be working now. So, arrow. See, the center of mass of this object is somewhere around here, a little bit above maybe for the little thing on top. Now, obviously the center of mass for this one is lower, which really you want to start at the same height. And you're really measuring how high they want to swing. So he has a coupled oscillator, but he's coupled them tightly so they're all bound to each other, and that you don't really need to do. So I'll try to explain that also. And the longer the pendulum, the better, obviously, also. Just point that out. So let me get to the other camera. I have to get rid of this there. That should fix it. Alright. So what I found doing the experiment, you don't even need an elastic. Okay, you're just trying to, so first thing you want to make sure you do is have the center of mass, even put a dot on the object, or something, but you want, really, ideally, you want to be able to have two objects that are the same size and everything looks right. Your dimensions are the same, so you don't have something that's thicker and it looks like it's moving more when it's not moving more, it's moving less, but it's just because of its thickness it looks like it's moving more. Anyway, that kind of stuff. But the point is this coupling doesn't have to be, see, he's got this coupling, so he's almost forcing the two pendulums into each other. You don't have to do that. So you don't need to put any stress on them. So you want to try to connect them, you want to keep them isolated as much as possible, so they're free to be independent to a large degree. So what I found was you didn't even need elastic, you just need to put a loop of anything, string, and then all you need to do is put a bead of weight on it. Okay, and that little tiny bit of weight would be enough to transfer the energy back and forth. It just going up and down would do the job of putting a little bit of stress on the other pendulum. Every time this one moved, you put a little stress, little stress, little stress, and that would work. So you can do that with elastic bands or not. But you can have no weight in elastic bands, or you can have no elastic, but you have an object that basically moves up and down as the transfer slowly takes place. And the idea is to really, you can make it so it's tight, and that way the transfer happens quickly. Just 2 or 3 swings, and then the energy starts going back the other way. 3 swings, it goes back. Or you can have it take 7 or 8 swings of the pendulum before the energy moves all the way to one side to the other side. I would argue that it goes stiller, okay? And you really don't want is both of them oscillating, because then you're not seeing the energy being transferred, because part of the energy is tied up in both of them oscillating. So that's what you want to avoid, essentially. You want it either to be all the energy over here or all the energy over here, not any motion together. So I guess that's those are just my observations of how you have to kind of, I think, improve this a little bit. But it'd be great if he can put the little cards on, or if he has objects the same size, then he could just let the objects go through the gate, I suppose. But then you got to worry about getting, the object would have to be a rectangle or something. You'd have to make sure that the size was the same. So that's the only tricky part, is having them move consistently, without twisting or turning. So should be doable, though, frankly. If even if you have to do the experiment 10 times and only one time it goes perfectly straight, that would be good enough, frankly. But I mean, you can have a guide string or something. There's different ways, I suppose, you could make sure that the two can't twist. But anyway, just an observation of your first construction which was very quick. I mean, I made my video this morning, and so I mean, this could use a little work, frankly. That's I guess all I'm saying. Before you invest the more time in creating a way of mechanically or electronically testing velocities, they have to be the same length of pendulum, and obviously when you kink the pendulum, you know, you shorten it essentially. So the way you've tied them together, you basically eliminated the length of the pendulum and made them much shorter than they have to be. The longer the pendulum, the better for visually seeing the experiment and seeing any flaws in it, frankly. Alright, so enough of video, and so see how it goes. So yes, this experiment really just kind of says it. It's either going to show kinetic energy being conserved, or it's going to show momentum being conserved, and it's going to show the exact opposite. So if momentum's conserved, kinetic energy won't be, and if kinetic energy is conserved, momentum won't be, which will be huge, because you have to explain where the momentum went. Because it's going to disappear and then come back again, and then disappear and come back again. So if momentum is conserved, well, yeah, that's understandable, frankly. But anyway, so we'll see how it goes.